And we will finish our discussion of the oligopoly by looking at the case where there are two firms competing with one another. An industry with only two producers is called a duopoly, as opposed to a monopoly. So here's an example from Almaty. There seem to be a couple of chains of grocery stores or supermarkets that dominate the industry. Double Mart and a green fruit or veg store. So we want to model the case in which each duopoly, that is each firm in the duopoly, is choosing how much to produce in order to maximize revenues. Since they have said marginal cost equal to people in the story, maximizing revenues amounts to maximizing profits as well. So to take a look at how much each firm is producing, let's go to the whiteboard. Our inverse demand function for the industry is very simple. The price is equal to 100 minus Q, where Q is the industrial output. So since we have only two firms that are producing, firm 1 and firm 2, industrial output is equal to Q1 plus Q2. So let's make that change in the inverse demand function. Okay, now consider the problem from the point of view of firm 1. Such as Double Mart. It can, of course, control its own output, but it cannot control the output by its rival, rent store. So firm 1's inverse demand function looks like this. The market price that both firms can receive is equal to 100 minus Q1 minus Q2, but Q2 is a constant as far as term 1 is concerned. So it's a treats Q2 as a constant. So we will denote this by defining Q2 as a constant to look like this with an underline. So from term one's point of view, the inverse demand function looks like this. And then there is the element that term one can treat as a variable. So revenues for Q1 look like this. Price times the amount that Q1 produces. For example, grocery bags of double mark full of food. And we've seen that for Q1, the price is 100 minus Q2. This is all the constant up to this point. Minus Q1 over this being the price times Q1 for their revenues. So to make this easy to manipulate, let's write it out. And there you have it. Notice that you have a squared element for Q1. So now let's choose Q1 to maximize revenues. And at this point, I will give you a couple of minutes to calculate the problem for yourself for 2 points of extra credit. So please try for 3 minutes to maximize revenues for double mark from 1 in the duopoly. Thank you. Okay, so what have you found out? So let's see. We have defined revenues as price times output of term one. So to maximize those revenues, let's differentiate total revenue with respect to output and then put it into the table. So let's see what is our derivative of firm one revenues, I'll call it R1, with respect to output one. So let's see, remember that this term in brackets is a constant. So differentiating with respect to 2, 1 gives us 100 minus 2, 2. The amount that term one presumes that its rival is producing. And then the second term, 2, 1 squared, is really easy to differentiate. Just minus 2 times Q1. And then to maximize revenues, our first order condition is to set that derivative equal to 0. The marginal revenue is the derivative of total revenues. Okay, so far. So let's see what we have. 100 minus the assumed amount produced by the rival then store minus 2 to 1 all equal to 0. So let's solve for output per megabyte to 1 and 2, 1 to both sides. So that this is equal to 100 minus Q2. And then divide through the 2. And we have an interesting result. The amount that firm one produces depends on the amount that is vital is producing. So now let us interpret Q2 as a variable rather than a constant. then to maximize revenue and therefore profits firm one will cut back for 1/2 of a unit for every increase in production that is rival of 1 unit. So, for example, if Vance Store builds an expansion of the supermarkets, Global North will respond by basically accommodating that decision. It will cut back on its own output in order to prevent prices from dropping too much. Because firm one is reacting to firm two, we will call this a reaction function. So in terms of a graph, the action function looks like this. Here's the output per double mark, and here is output per rival, then store. The action function for double mark is linear. Just like that, with an in this amount that falls as Q2 is rising. So we have a negative relationship between output by rival and output by double mark. If Q1 is equal to 0 in this case, then what is Q2? Judging from the reaction function. Now let's see, if Q1 equals 0, then we have the 0 equals 50 minus 1/2 times Q2. So let us solve for Q2 by adding this term from to both sides, and then solve explicitly for Q2 by dividing through by 1/2, or that is multiplying by 2. And there is the intercept on the vertical axis to turn what the action function. But and then of course, if Q2 equals 0, Q1 would be equal to 50. from the reaction function, the Q2 is not zero. So our horizontal intercept has the value of 50. Good. Now, the problem for firm 2 is exactly the same as for firm 1. So we can write down the reaction function for firm 2 as Q2 equal to 50 minus 1/2 times Q1. So again, we have a linear function in a negative relationship between the outputs of the two rivals. If Q1 equals 0, then Q2 is equal to 50, and if Q2 equals 0, Q1 is equal to 100. So if that's not clear, all that I've done is to take the reaction function Q2 equal to 50 minus 1/2 Q1, turn it to 0, and then solve the Q1. So we have from the reaction function 0 is equal to 50 minus 0.5 times Q1. And then solving the Q1 gives us 50 on the left-hand side. We've added this term to both sides. And then divide through by 1/2, which is the same as multiplying by 2. So there is the second reaction function. The vertical intercept, the true one is equal to 0, is 50. And then Q1, given that Q2 is 0, now equals 100. So there is the problem of determining output for each of the two terms. We have a solution at the intersection. one way to interpret the result is in terms of the action step by step to what the variable is doing. So, for example, suppose that Q1 government begins by producing for 50 customers per day. Now, firm 2 will pick up amount at Q1 as given and then respond with this point on its own reaction function. Looks like maybe about 25. Next, firm 1 will react to that amount to the firm 2 by cutting back on its own reaction function to right here, and so forth until we arrive at an equilibrium where there is no longer any incentive for either firm to change its output. So we can call these dynamics. Turn 1 begins the game because this is truly a game between turns 1 and 2. And so forth until we arrive at the intersection of the two reaction functions. At this point, there are no longer any adjustments to be made. So this is an equilibrium. Since both firms are thinking about the problem in the same way, they will produce the same output. We have that Q1 is equal to Q2, or the action function is determined Q1 for firm 1. So this is equal to 50 minus 1/2 times Q2, and the same thing for Q2. It's the action function is 50 minus 0.5 times Q1. But Q1 equals Q2 in the equilibrium. So let's make that change. and I have a mistake in my math, but the solution is 33.3 for both terms. Right there. So now you can determine the market price as well. Remember that the inverse demand function for the industry is 100 minus industrial output, or Q1 plus Q2. Or 33.3 minus 33.3. That is, the price is about 33.3. So the main point to note is that each firm will choose an output level that reacts negatively to production of the rival in order to avoid lowering the market price too much. Each firm reacts by lowering its production by a fraction of the increase by the rival. For a duopoly. And there is another way to arrive at the solution. Since the inverse demand function is linear, marginal revenue has the same intercept, and then a slope that is twice as steep as for the inverse demand function. So to maximize revenue, set marginal revenue equal to zero. And then there is the solution. So, so far, we have assumed that the duopolists are competing on the basis of production. As each firm changes its output, its rival will adjust. But another possibility is that the two firms compete not on the basis of production, but instead on the basis of price. So in our example, suppose the price is equal to 33.3, and we have the marginal cost is equal to 0. So when firms compete on the basis of output, they guarantee profits for one another. Since the price exceeds marginal cost, now suppose instead that each firm competes on the basis of price. And then will permit the competition to determine how much to produce. So now, firm one observes that it can still profit by lowering the price a little bit. Say to 30. And undercut this Bible. So now all consumers are including the firm one, that is the Gallagher, because it offers a lower price than firm two does. But firm two now reacts. It now sees the essence of the game, then it will cut its own price. Say it's 25, still making a profit, since marginal cost is 0. And it now steals all of the customers from term one. And the price competition continues. So for 1 point of extra credit, what is the equilibrium in the street for the price? Of course, both firms continue to undercut until they reach the point at which another price cut would be expensive. In other words, they put to the point where price equals marginal cost, in this case, zero. So the competition looks very different in results, depending on whether we are competing on the basis of output or on the basis of price. We will call output competition to the duopoly to no competition. Named after the French economists who first thought about these problems in the 1800s. And price competition is Bertrand competition. Okay, so now let me take a moment to go back to the calculations behind criminal competition. We had the action function to Q1 of 50 minus 1/2 of Q2. But Q1 is equal to Q2 since both firms are thinking about the criminal competition in the same way. So let's make that substitution. Q1 to Q2, and then solve to Q1. By adding this term to both sides. Simplifying, we have 1.5 times 2 equal to 50, or 3/2 times Q1. So now, solve explicitly to Q1 by multiplying through the 2/3. Or 33.3 to Q1. And the same logic holds true as well. So that is a map of behind the kernel equilibrium. Questions about the duopoly. So the main point is that we get a lot more competition if this is on the basis of price rather than on the basis of output. And for extra credit, you can show those results extend to the price function. For additional extra credit, use the inverse demand function that we have and solve it again for perfect competition and for monopoly. So in the extra credit assignment, use the inverse demand function of price equal to 100 minus industry output for each of the three cases that we have examined. Perfect competition monopoly and duopoly on the basis of output. So remember that in perfect competition, the price is equal to multiple costs since firms compete by undercutting the rivals in price. And then for the monopoly, the price exceeds multiple costs. Just the firm to output at the level the marginal revenue is equal to marginal cost. So since we have a linear inverse demand function, marginal revenue in this case is 100 minus 2q. Use those results to solve in each case for output, price, and profits. good for 15 points and do Wednesday if you choose to do the problem. Last time we had discussed this interesting game of Pinto Really, Mo, and Curly in a duel with one another. Then he goes first and has to decide what to do. Should he try to shoot Mo or shoot Curly instead? So this is a sequential game that is each player is moving in turn and in the action to the other players. So what should we do? Have you found a solution to that problem for extra credit? Look, let's see. Suppose that Larry, who is a poor shot, shoots low. Then he eliminates Mo from the game. So the next shot goes to Trilly, but Trilly never misses. But he kills Billy, and at the end of the game. So that does not look like a very appetizing strategy for Larry. Another possibility is that maybe Larry will shoot into the air. He does not try to shoot either Curly or Mo, and instead leaves it up to those two to eliminate themselves. If he just missed a shot, then Mo is next. Certainly, Mo will try to kill Curly. And if he succeeds, the next shot goes to Larry, who has some chance now of survival. So if you enjoy games I will let you show for next week that Louis' chances of survival are greatest if he risks the first shot. And that concludes our discussion of oligopolies, but duopolies in the games as well. Questions up to this point? Okay, then in the reading, please move on to pricing by the monopoly that maximizes profits in chapter 6. Thank you for your time, Trustee Daniel.